Welcome to another episode of Playing with Inference, a podcast focused on the intersection of generative AI and games. Today's episode, we're diving in deeper on broader machine learning within game development.
Our guest is Jorge Val, who is the co-founder and CEO of Latent Technology, where they work on generative physics animation, basically using AI to generate physics-based animations in real time. Prior to Latent, Jorge was a research engineer at Embark Studios, and before that, EA. Jorge, welcome.
Hello, guys. Great to be here.
Thank you for coming. So I think something that is interesting right off the bat, without getting into Latent yet, is that we've talked to people in the games industry. We've talked to people who are more from the ML AI side. But I think you're the first one we're talking to someone that is from the AI ML side within the games industry for as long as LinkedIn allowed me to check. Any comments on that?
Yeah. I typically meet people who are the other way around. I came more from a more hardcore AI background, and then I digged into the game industry. So yeah, I guess that is another perspective.
So I imagine that you've been in AI ML as long as you've been in the gaming industry, or were you outside of the gaming industry at some point?
I was outside as well. I was doing some research at university way back. It was not that much on AI as we know it. It was more in game theory and more things related to optimal control theory and some theoretical stuff that was very cool. Then there I started to get very interested in deep learning. And back then it was start of generative adversarial networks, which I thought super interesting because it was related to game theory as well. And I did a bit of research in that. And then I actually joined a bank in an innovation division, which was not very bank-y. It was more fraud prevention and the detection of fraudulent transactions and more other kind of activities as well, more related to even blockchain. So I did a variety of things. And it was then when EA found me and I moved to Sweden to work in games.
I think another piece that's really interesting about your background is not only have you been in machine learning for a long time, but you've very specifically been on the research side, right? And I think I remember before LLMs were anything that anyone talked about, seeing videos come out of Ubisoft research and Electronic Arts research and all these places where it was really just, hey, we're playing with this deep learning stuff and we're just seeing where it goes. And it's not tied to a game, right? I'm curious what that sort of experience was like on more of that research side of those things, because you weren't on a specific game, right?
Yeah, I wasn't working a specific game. I was in a research division initially called SEED, that stands for Extraordinary Experience Division within EA, and we did a bunch of research in a lot of things. We did publish some research in reinforcement learning, along with my co-founder Jack, actually, bots that could play Battlefield, for example, when the possible combination of actions just exploded because you could do permutations, and we figured out a way to make that work, and that gained quite a bit of reach as well, and a few patents on that. So yeah, not on a specific game. And I started in the industry at a very interesting time indeed, because it was on the verge of two simultaneous revolutions. One of them was the generative AI revolution, and the other one was the robotics and reinforcement learning revolution. Interestingly, for reinforcement learning, video games was always a target at the beginning. In 2013, DeepMind published this amazing paper, DeepQ Learning, that showed how you can learn to play Atari automatically only from pixels. That completely baffled the industry, right? And then they started to expand on that. And it wasn't until, I think, 2018 or so that Peng extended that framework for character animation or character movement, right? Where you have a character and the character learn to move by itself physically and learn to imitate different kind of animations. That was at the start of something, and we picked up on it. We were at the right place at the right time. And then the robotics kind of revolution started going, and even Boston Dynamics were not even using reinforcement learning back then. They started using it later. And then the generative AI revolution. I was there when generative adversarial networks were the best of the things. I gave a talk at GDC in 2019 that was titled Towards Deep Generative Models in Game Development, where I discussed some of the possible avenues that generative models could have in game development. And if you go and watch it today or read it, it's, oh my God, so much stuff has happened. We're not good at all. The image generation models were not good either. OpenAI surprised us all when they published DALL-E. To me, that was the biggest mind blown that I've had in a very long time. I didn't expect it. Like that quality and controllable for art creation was just amazing. And almost simultaneously with ChatGPT and the quality of those language models, it was something that caught the industry. Yeah, the industry was not really knowing what was coming so fast. It was a very interesting time to see all of that being cooked essentially by academia.
It's funny that you mentioned DALL-E, because for me, I often pinpoint the moment when I decided to move into games to when DALL-E came out. Because as you said, it was just shocking. Now it looks like ridiculously bad, but at the time it was unbelievable. But somehow I think you can make some sort of, if you're in GAN territory in the 2010s, you could already imagine the trajectory of going from we're using GANs to DALL-E is possible. I think what really shocked, I think meanwhile, the NLP side and natural language processing side, I feel like it was much more sudden, right? The images were getting better in a gradual and surely and steady way. But the natural language, at least for someone who wasn't doing natural language, it was very sudden. Oh my God, GPT-2 came out, and then GPT-3, and it's game on.
For me, it was actually almost the other way around. Because even in GAN territory, if you go back to that, I think 2016 paper when they published the deep GAN, the deep convolutional GAN, you see the images that were, 64 by 64 of bedrooms, and they show that you can interpolate between two different bedrooms. And that was, wow, amazing, right? That was kind of the state. They started to make it bigger. There was something called the Big GAN as well that showed that you can make them a high resolution, but the artifacts were just, there were a lot. And it was definitely not controllable, which was what impressed me the most. The fact that you could control with that quality, the generation with text, and that there was an understanding of the text of what you wanted to do, I thought that was amazing. And of course, it was tied to the advances in natural language, because the way to understand text was tied to that. But yeah, the jumping quality of these languages that could talk to you, the languages, these models like ChatGPT was amazing as well. It was a big moment in the industry.
Yeah, I think the interesting thing that I always try to tell folks outside of games, because I think folks within games sort of understand this, is that games has been the target of variations of what we call AI technologies for a long time. It has been a big center of where that technology not only gets implemented and tried out, but also, to your point, researched and even developed, right? And I think, my soapbox is that there's a reason for that, right? Games are a very complex system space that require a lot of stuff, but it's also a very safe space to play, right? But to your point, if you're testing something for robotics, doing that in a digital environment, in a game system, is safe, whereas otherwise you have to build a robot and who knows what the robot will end up doing to your physical infrastructure when it's learning all this stuff, right? I think what's interesting now for sort of this arc of LLMs and generative AI around it is it's actually one of the times that I've seen a lot of machine learning and AI research and development go outside of games and not be done within games. Almost every use case we're really starting to see pop off has been much more consumer or enterprise, and actually the adoption into games has been relatively low. Being sat inside game studios in these innovation hubs and research centers, does that surprise you? Or are you, I never thought it would come from inside of games. How has that been for you?
That wasn't surprising to me too much. AI has had a lot of applications outside of games, but just not the kind of AI that we're seeing today. Businesses have been using automatic prediction of stuff for a long time. And anything that requires interacting with a human was going to be affected by AI. Now, creative processes as well, which are not limited to games, obviously. So, yeah, that didn't surprise me. It's satisfying to see that some of all of this research is actually getting into games in a productive state, because I saw it a bit of the other way around, that game studios were very reluctant to use this sort of new technologies and new research into production. And I was there trying to make that happen, right? But it was hard because of the risk tolerance that these studios had. But now, since all of this technology is being validated, we're seeing much more adoption. And also, for example, for LLM technology, the investment is lower and the risk is lower as well, because everybody's using more off the shelf models and API calls to some established models. So yeah, it's interesting to see. Still, there's a lot of resistance for like bigger studios to use AI, and even smaller ones. There are a lot of challenges to really, really use it.
So I think that's a good segue to maybe hear out what you're actually building. I tried to give a mini preview, but probably hear it from the co-founder himself. Tell us about Latent Technology. What are you guys doing? And then I have some game ideas, and I want to hear what it takes to use Latent to make these happen.
Also, yeah, well, at Latent, we're building a new technology which allows animation to happen as you play it and being grounded in physics. So we're trying to produce a shift from pre-baked animation to emergent physical behaviors that you can actually author and you can just play with without the need of animating every single thing. And this produces different things. Of course, the workflow to animate in a game changes with this, at least part of it. But what excites me the most is that this makes its way to the user too. Because interacting with a character in a completely emergent and physical way is a different feeling. And you need to try it out. We have seen some games that had like ragdoll mechanics in them, right? But they were very janky because it's actually a really, really hard problem. But they were very engaging for this reason, because there was an infinite range of possibilities that you could interact, an infinite number of ways that you could interact. And I think that is a big wow effect for the user. And that's what excites me a lot, because typically players don't care that much about how long the game took to make, or how expensive it was, or how many hours, or how many people. The players care about experiences, right? They want to say, wow. And it strikes me that for a long time, players have been forced to settle for incremental performance increases, better graphics, things like this. We've used the power of consoles and all of that to give the users bigger worlds, better graphics, and better performance, while a lot of these results that we could be using for the experience of the user are not there, right? So simultaneously offering an alternative in both the experience of the user and the workflow to create those emergent behaviors is something that excites me the most, the combination of both things.
So just to clarify, what I have in mind here is, when you say emergent animations, is they react as a human or as a humanoid would, given the physics of the situation. So if given a specific gravity and specific wind force, actually given a set of forces applied to that body and the intent of that body, so maybe it's trying to go to a specific direction, its movement and its reactions are going to be based on that. Is this a next generation of ragdolls, or is this, I'm trying to get a sense of, does it go beyond the animation, or is it the way that it acts also affects its environment, and does you have change?
Exactly. That's exactly it. The reaction of the agents is produced directly by the environment, as if they were there alive, right? And making a parallel with the real world, we humans, we're not animated. We were not born with a data set of thousands of pre-baked animations. We have behaviors inside. We have a brain that prescribes the force of the muscles in every possible situation, and then we sort of roll with it, right? So it's the same thing, but for video games. Essentially, we're trying to make them be alive in one way or the other. Once that they are in the game and they are physical assets, you can add wind, you can have an obstacle, you can make them crash into each other, you can shoot them and apply brute forces, and then they will react to the bullets. Not because you have animated the reaction, but because there is literally a force being applied. And every interaction will be unique by definition. You design a level or a game or something that the game has a cliff, and you take the character there as a player, your character will fall because it's physical. And I think this is super exciting. And in traditional games, there are always holes with the thousands of animations that they have. We've all seen the guy trying to walk towards a wall and keeping the walk and these glitches. This wouldn't happen here because by definition, characters are emergent and lifelike, and their movement is given by physics and their own behavior.
You talked about the muscles. So is the idea that you are having actually, and let me try to understand what's going on behind the scenes. You're training some sort of ML model or deep learning model, runs on the device. It has some sort of low level control about the muscles or the actuators of your ragdoll or character. And the part of that it's less clear to me is it has a target state that it's trying to get to, and then you have what you're doing, generating the policies given the effects on this character and its desired state is just generating. Is this model generating the actuators required to get there? Mm-hmm. Is that basically more or less what's going on?
Let me explain. So in this setup, characters are adults. You said it yourself, but they have muscles, which is the ability to apply a force to their body parts. In our case, right now in this version, they are, for example, PID controllers. And if you were just to have that character like that, the character would immediately fall because of gravity. And just standing still for us humans, it takes an immense amount of computation. And what we do is we have a model at runtime, which infers the best next action to give their own muscles. It could be like you need to activate your arm and your feet. And we train these agents with reinforcement learning techniques. Well, it's a mix of a lot of things. We call it generative physics animation. It's a kind of like generative reinforcement learning that has motion capture data into account, but as well tries to control their own body in a way that they won't fall. So we are creating a foundation model, so to speak, not the same kind of foundation model that we're used to talking, that just knows how to move from a lot of motion capture data. This model will constitute a foundation for this kind of emergent behaviors. Once that we have that, we can train other models that, for example, try to reach a target, but the agent will figure it out using the skills that the agent has learned previously. So we have locomotion models right now, for example, that have as the inputs the target that you want to reach and the style that you want to have while you walk. That's what we have right now. And with that, you can make a lot of stuff by itself.
As a developer, I want to understand, where do you see your guys plugging into sort of the game development stack? There's lots of folks who are going after sort of tools where it's, the animators used to use tool X, now they use tool Y, right? Instead of hand animating a bunch of stuff, then you could use text animation or whatever. But it still generates kind of an asset library that goes in. On the other side of this, probably the other extreme side of this, you could say, this is maybe not how they would classify themselves, but you could take something like a world model that's done by Odyssey or any of these folks that is really trying to replace the whole game engine, right? You don't have a game engine, you just have these frames generated magically on the side that replace your whole game engine, right? Where on that, it sounds like you're a combination physics engine and you don't have a traditional animation engine anymore. You have this instead. How do you guys replacing and where do you plug in?
Mm-hmm. Okay, so there are indeed companies trying to replace a very specific part of the stack. But the kind of games that you can create with that, they're essentially the same. They can tell you, this part we're going to generate, but the rest is the same. And that's very easy to understand. Other companies are trying to do very ambitious things. Odyssey, for example. We are a bit in the middle. A developer will be able to download the API, for example, for Unity, and turning it on and off wherever they want in the game. So imagine that you have animated a character in your game. You have everything. You have the walking, you have dancing, and you're happy with that. But now you want to enable a player or a character to just throw balls on it, or you want the character to walk on terrain, or you want the character to interact with their environment in a wow kind of way. For those situations, you can turn latent on, and the character will behave in an emergent fashion using one of the behavior models that we offer. Very soon in the future, we will release what we call the behavior engine, which will allow you to author the behaviors that they will play when latent is on. So where in the workflow, it depends, because with this you can make a different kinds of games as well. And therefore, it doesn't need to fit in any specific part of the workflow. You can turn it on and just allow the characters to behave and emerge and direct them rather than millimetrically animate them. So it could substitute the whole animation pipeline if you wanted, or it could coexist with it.
What about the physics? Oh, go for it, Carl.
Oh, I was just going to say, I will warn you that the idea of a dance animation will come up momentarily when Ramon gets to his game ideas.
This time is not about dancing.
Oh, no, you have a whole new... Okay, great.
Yes, we're trying different games. We should bring up the dancing question. I was going to ask first, how does it fit within my physics engine? If you're using Unity, you're probably using either the stock physics engine or some custom one. I'm using Godot. I am using currently Jolt. How does it, 'cause this is supposed to be very physics based, so presumably it communicates on a high bandwidth channel with your physics engine, so it knows what's going on.
No, it's simpler than that. When you create a rigid body in Unity and you hit play, the rigid body falls, and it's using their own. They're using physics, for example, in this case. So we do the same. We model a character with physical assets, which are part of the game engine in the case of Unity, right? So on training, we support different physics engines. In the case of Unity, which is our go-to, so to speak, right now, we are supporting physics, but you don't need to do anything else regarding the integration. Integrating latent into your game, into Unity, it takes 2 clicks. There is a window saying import latent, and then the character appears and you can skin it and all of that. And then you hit play and the character is already running. So it doesn't really require any further integration. As we go, we integrate with more physics engines,
Yeah, how about the pathfinding? Or if there's the behaviors with respect to a given action that I'm doing here, but then, and I'll touch on what I have in mind. And then there's, if I want to make a new game, a new experience, then presumably a lot of these actions depend, not only the animation, but what the character does also depends on the environment. So there's this, I feel if you're talking about, and this is probably the reason why a lot of companies start there, if you're trying of just swapping the animations, there's a clear point of entry. Whereas if you're talking about, oh, we are hooking up with the physics and we want you to build games that are more emergent. And if you're really trying to sell this lifelike humanoids, then I feel there's a lot of points at which you have to connect. And I wonder how does a developer deal with that?
Mm-hmm. Well, for very specific points, the famous dance animation or picking something up that you wanted to do in a specific way, you can just turn the traditional animation workflow on and use character latent for the rest. So that is not a problem at all. As we go, we will allow behaviors such as picking up stuff, and you will be able to animate or to author these behaviors yourself to be happy. Instead of authoring pre-baked animations, you will be able to author emergent physical behaviors, right?
Author situations, and then the situations themselves let the
and the pathfinding, that doesn't come into this. This is one level before the actual pathfinding, for example. You can tell the agent where to go, and that can be the output of a pathfinding algorithm. That's
here's why I was asking. When I first heard of Latent, the first thing I thought, I think this was last year, and at the time, I had just finished The Expanse or something like that. I was obsessed with The Expanse. I'm still obsessed with The Expanse, but less so. It has faded a bit. One of the things I love about the scenes in Expanse, and I haven't read the books, I've only watched the show. One of the things I love about The Expanse is this is a hard sci-fi because it's not fully hard, but they try to stick to physics as much as Hollywood would tolerate it. And one of the things I love is these scenes about space battle where the people inside the spaceship are constantly being subject to different types of gravity. It's not gravity, it's accelerations in different points. So the ship is rotating, they get smacked into the walls. They're accelerating because they have to catch up with someone. Gravity goes to 5 to 10 Gs and then squashed in the ground, right? So there's a lot of this. The actions of the spaceship have a very real and immediate consequences on the individual, on the crew. So you have to plan, they have to strap down there. There's all of these plot points where it's dangerous to not be strapped down. Anyway, I want a game like that. I want a game where you can explore, where maybe you have some sort of two levels. One where it's like the pilot has this more high level view and it's fighting the other spaceship, but then your maneuvers put your crew in danger. So your characters have to be plugging holes and fixing things because you're being shot at. But at the same time, every time you do a maneuver, you have a risk of killing your crew. All of this to say that, in my view, if you're using Latent, it sounds, for me, very clear use case of Latent. But then in space, if you're just floating, your animation, there's almost nothing you can do to change your state. So you're just doing this. That's why people wobble when they are free falling. But then, I don't know, if I want to project, you want to move to some other direction, the way to move is you have to push against walls, right? And that feels to me a combination of your character has to do this push movement to get to the point where I want. So that's why I was talking about pathfinding has to involve this push actions that have to be coordinated with Latent or with the animation system. And if I were doing it in a more prescribed, a more traditional way, then I will know, I want the animation for pushing against the wall is here and it's pre-baked. But if I wanted to do more emergent, I wonder how that looks like in a world where I have all of this physics animations.
It's a very specific edge case when the characters are just floating. But look, let me reach a middle point here. Imagine that you are on a ship of your team and there is gravity, but a little bit, or maybe a lot. And the ship is sinking and the gravity changes, right? So they might get smacked against a wall or not, or the characters might start to bump into each other. How would you do that traditionally, right? Would you spend a lot of, I don't know how many hours animating every possible thing for different possible gravities, for different possible character interactions? This is a perfect example of, you want an emergent game. And I think these kind of games are going to be the kind of next generation games that we're going to see in the next years. The kind of wow moments that you can get in a game when your spaceship switches the gravity and all the guys are smacking into each other and they might reach into each other and grab each other, but maybe one of them falls off, and that is not scripted. So the players can say like, wow, and they want to tell their friends instantly. That is what you get with emergent gameplay and emergent physics. You get wow.
I guess my question is, when they grab, so maybe a higher level view of this is that you have, in robotics, you have a more task planning view, which is more high level goals. It doesn't say anything about the specific controls and actuations that you need to do. And then you have low level control, which is more for this trajectory tracking or for actual concrete goals that you want to get. And those two have to talk to each other. And in games, it feels to me Latent is very much on the low level control type of setup. So directly dealing with the actuations. And the task planning, which would be more, I don't know, GOP or whatever you're doing in your game, is something that you hook up with. But for a lot of these experiences that, at least just if I think about how either this Titanic sinking or the spaceship moving around, you sort of want to combine both, right? You want your individual movements have a very important role to play in the high level task planning.
Yeah, I completely agree. The high level task planning and they should be connected and interacting with each other. So we offer an API that can communicate with high level planning. And with traditional animation, you would do the same, right? Like you would have a huge animation tree with a lot of blend trees in between. And you will need to say, okay, now you have to walk and you need to walk there. So we are doing the same thing. We wouldn't take care of that part. And it seems to me as well that you're bringing a point that is a very good one, which is the trade-off between control and emergence.
Mm-hmm.
I don't know if you meant this. It's a trade-off that has been forever in AI, right? The more that you let the AI do, the less control that you have. And it seems that people don't want to be in the completely emergent, you don't know what's going to happen point. But the other point, which is the one that we have explored, is not the best either. Then we are stuck in the same situation forever, right? So there is a sweet spot in the middle, which is what we want to reach, where you can direct very well your characters, but you don't care that much about the details. Imagine that you are directing a movie and you tell the actors, okay, now go there running, but run very scared because there's a monster chasing you. You do that. You don't tell the actor, okay, and now in this frame, move the feet like this, and in this other frame, a little bit more. You don't do that because you don't care about those details. You care about the features that are important to you. That's the sweet spot. And that's what we would ideally like to reach, where you can, with course directives, get the behavior that you want without having to care about everything. Because anyone can make an interactive experience as well. Animation is a huge barrier. If you just take Unity and you want to create your dream game, you won't necessarily be stuck in 3D assets, but you can download them, or in the scripting of the game or something. When you come to animation, you will start having problems actually. So if we can help with that barrier as well, more and more people can do video games, and indies can start making video games of much more wow effect and much more quality.
As you come in and you're pushing people towards that sort of emergent side of games, take someone going pretty deep into what's now possible to think about how we integrate this in a way that makes that emergence fun and creates a game that is centered around that emergence, so that emergence always has to be balanced out of, like, you have to be able to learn something about it, so cause and effect has a little bit of connective tissue. I'm just curious, how long does it take for someone to really understand what's all going on underneath the hood with the latent animations and this stuff, where you can really start to build games around it?
I think that it won't take a lot of time to understand and to learn to use it, because one of the key points for us is to make it very, very easy. When you give course directives, is easier than actually having to deal with, prescribing each frame and scheduling them together in a blend tree or in a whatever. It's much easier, I think. But users and players need to see not just the how, but the what. And we're trying to do that by building and shipping tech demos, which are actually playable. Because it's hard to explain exactly how it feels, right? One of the tech demos that we are building, I don't think I've ever said this, but I said it in this podcast, it's going to be a VR experience. And in this VR experience, there are going to be zombies involved and hospitals. So when you're playing them, you can literally grab the zombies and punch them, but there are 0 animations involved. And the feeling of literally punching zombies around with a crossbow, you can impale them into a wall and all of that stuff, when they can fall onto each other and on this scenario, and it's a lot of chaos, is something so satisfying that the what is very clear there, those moments. If you have motivation about the what and you want to differentiate yourself by bringing a different kind of experience as well, you will learn the how much better. And especially when the how allows you to do things that were not possible before with more quality at a fraction of the time, because there are not animations involved when you are directing like this. Look, I think if interactive entertainment is a circle, I think current animation workflows are like trying to fit a square to that circle. And you can put much more squares. You can make a lot of different squares and try to make it look sort of like a circle, but it's never going to be a circle. It's a hack, right? Even in the limits. In this metaphor, each square is obviously pre-baked animations. And if you want it to look more like the circle, you are going to need to spend more time, energy, and money making more and more and more and more squares. Emergent physical behaviors are like circles. They're something different. And this workflow is going to allow you to reach a circle much, much faster and with a workflow that is much, much better for the developer if they want to reach this kind of experience.
So on this question on the what, I'm now thinking that probably I would love to have some sort of sandbox version of Latent where I get to easily create some dumb scenarios and then see what happens. I'm thinking, what is it? Is it totally accurate battle simulator tabs? I've watched countless hours of YouTube of that, and I've never played it, but just there is something very satisfying about seeing dumb ragdolls get impaled into death by all types of different projectiles. And I'm thinking, so I think that there's two, I've touched on this on the podcast before, but I feel on the one hand, there is this microdosing games current where people just, their games are meant to be just watched on YouTube and one person plays, millions watch. And I feel like this could have a version of this, like tabs, but even more totally accurate. And at the same time, I feel like if we talk about LLMs, to draw an analogy, we've all, like a lot of people like us have been working and trying out different games where we use LLMs to find out where it works, where it doesn't work, what is interesting. And to a large degree, just having ChatGPT there, it's like a cheap, crappy sandbox for us to say, is this interaction going to work? Like if I say this and that, will the reply make sense in a way that I would have wanted to be in the game? And I wonder what is the equivalent for a generative physics setup, right? Like what's my, I'm going to boot up the latent box and throw, I don't know, spears made out of bananas to knights on full armor. How does that look? What happens? Is that going to work in my banana kills the knights game?
Yeah. Well, we have thoughts around that. I won't say much more than that. However, the Unity API that we have, that we will release soon publicly, by the way, it's a bit of a sandbox. Like I have so much fun just creating absurd situations that I can do in minutes, putting a guy there, shooting arrows, creating, for example, a component to stick the arrow, and then start shooting and increasing the firing rate, making them cannonballs instead, and just seeing what happens. And then I put 10 guys instead of one, and I do the same thing. And what happens, right? And then I put two armies of people shooting each other. And like the iteration speed is way, 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 way faster than with a traditional video game. And that is super sandboxy by itself. And I think that you brought a very good point about what kind of absurd things people watch. Like if you go to TikTok, you're going to see a lot of falls, fails, etc. Totally accurate battle simulator is one of those. And even I realized that if you look for GTA on YouTube, what you will get the most of is characters just running away from a motorbike, crashing on a building, crashing onto another guy, running over. Like that is the percentage of those kind of videos versus the others is ridiculous, right? So you make a multi-million-dollar game, and what people like to share then is this kind of emergent situations.
Yeah.
By the way, that ragdoll technology, which was made by Natural Motion, and it was called Euphoria, and then they picked up on it. That cost millions of dollars to license and a lot of time to integrate. We're talking about an evolution of this that can be in the hands of any developer and any kid out of university and any AAA studio if they want to dig more into this. I think that's very powerful, especially when you pointed out that exactly that this is fun to watch. It's fun to watch even just kids or humans just walking around and see what happens. You don't really know.
Yeah, you need to make, to Ramon's idea, you need to make totally accurate epic fail simulator and just have that going. I mean, I think it's an interesting point on two fronts where so much of that sort of fun and sharing of that emergence and those wow moments that you talk about often become the pieces that do go very viral, they become the content creator engine that will drive a game or can drive a technology and can drive stuff. And also where a ton of those really interesting, fresh ideas come from. I think when we think about AI native games and what does that mean, we'll see a lot of that come from more of whether it's the mod space, the indie developer space, the UGC space, because those are folks that are just willing to dive in and they don't feel constrained by big development and stuff. I think it's, you're talking about going out on Unity, which I think is this interesting middle ground where if you think about the Unreal Engine, that's really aimed at professional teams of developers. Unity ends up being aimed more at indie developers that could be teams, but also can be single developers. And then sort of on the other side of that, you have something like Roblox, which is true UGC, anyone can make it very quickly. I'm curious, when you target Unity versus targeting something that is almost more of a UGC Sandbox platform, was there a particular angle on that? Do you see it as a good middle ground, or why not go even more on the UGC side where, to your point, kids are just going to make dumb TikTok videos of bananas and skateboards and trails in something like Roblox that really caters to that almost emergent playground feel?
Mm-hmm. There were many reasons for this. Some of those were technical. We need to have a deep integration with the game engine itself. And we could do that in Unity. That would be very hard to do with Roblox for many reasons, for example. And it was faster to develop in Unity, at least to integrate with Unity. Unreal is something massive, and they use their physics engine as well to use chaos, which is a bit harder. So, and Unity also includes indie developers more than Unreal, even if that's shifting a bit. That's the thing. And the first ones to use this will probably be indies, and I respect them tremendously because they're the brave people that have the crazy ideas and that are all in for trying to bring something new to the market in a market which is already saturated. So it felt like a good strategy to support them as well first, while giving a taste to the AAA studios of what you can build with this. We will have Unreal as well support, hopefully very soon, and eventually we plan to support other physics engines. So Latent will be everywhere. But to start with Unity felt like a good idea.
Got it.
I have a tangential question. So interrupt me if you want to stay on the storyline, but the game I'm building is not humanoid. Actually, we have a stock character that we don't care about. It's just for you to be embodied and do things. Your protagonist is the monster you're commanding with your voice. This is a true monster trainer. Obviously, monsters are not humanoids, and they tend to have different types of limb systems. Mm-hmm. So every time I talk to either you with this more physics-based animation technology or reaction technology, actuator technology, and other companies that are doing generative animation, there's a lot of emphasis on the humanoid side. And I think this is discriminatory to the creatures that are not... I'm curious... I mean, there's an obvious reason, right? In that we have a lot more data about how humans behave and how that gets replicated. Also, there's clear audience things. People love to watch people do an observant thing. Even apes are in love of watching apes if you give them an iPad. So there's some good reasons for why this is a thing. But I wonder, what's the shortcut version, right? If you were talking about your training, or a high-level version of what your training system looks like, where you have a pre-training setup with mocap data. This is what I understood. You have a pre-training setup with the mocap data, and then you have an RL stage where you're actually trying to use the actuators and use the pre-training primitives to get that animation or that set of actions that get you to your target state. In a non-humanoid character, you don't have that mocap, right? So I wonder what are ways to shortcut to either generate that fake mocap version, or if the existence of or maybe the existence of the humanoid data gives you enough data to hack how do muscles in different configurations would have to behave? Or do you have to actually solve for a given situation? You have to actually do the hard solving of this is the perfect set of muscle activations that move your, I don't know, spider from this position to that position. I'm wondering how would it look like for not humanoids?
It's an interesting problem, isn't it?
Yeah.
Not just for physics-based animation, but for animation in general. And people
Yeah.
are tackling that in academia for a long time. Like retargeting is a long-standing field of trying to automatically pick up some patterns from one kind of humanoid and transfer them to a dinosaur or something. That's been happening in the industry. And there are a lot of avenues to tackle this problem. We have a few ideas, and it's definitely on our backlog. We want to nail humanoids first for a lot of reasons. It's the most common rig, and it's the most interesting reactions when things happen to them, more than a dog, for example. So we picked humanoids. But yeah, prescribing how the non-humanoid creature would move and sort of add priors to that, what we call prior. That's one of the ways. Trying to generate the data could be another, even though it wouldn't be physical. Trying to retarget. There are a lot of avenues for that problem.
Now I'm just imagining Ramon setting up a mocap stage with little ping pong balls on spiders and a lot of cats running around with ping pong balls.
If you do it, please send it to me.
Yeah. One question, it sounds like it looked like Ramon had a follow-up, but one question I had really quick, because this is a presupposition to some degree of Ramon, is how, for something like what you're doing, how much pre-training mocap, I forget the term you just used, data do you need for your solution? Because I know that Ubisoft has been putting out machine learning, deep learning papers on animation forever, which I don't know that they've done anything with other than publish the paper. And I know that they had a whole thread for a while about trying to make it where they need as little data as possible, right? Oh, it can just watch a basketball game for 10 minutes and then it can do basketball animations, right? And so my question is, I think all of us sort of assume from the LLM world, oh my God, you need trillions of data sets to build a model. How much spiders does Ramon need to put ping pong balls on in order to get a spider creature out the other side?
Very, very little if you want to go to the extreme. The more, the better, obviously. But if you go through the website and look at the stuff that we shared, that was made with very, very little motion capture data, minutes, things like that. And we are scaling up. Scaling up in data for physics-based systems is actually complicated. There is not so much research on how you can scale up. And when you talk about reinforcement learning, you get much more problems than just with traditional machine learning models. So we needed to figure that out. And we found a way, and we're scaling up. And very soon we will release the API with models trained on much more data, which are much better for the environment interaction. So it depends on at which level are you willing to settle, right? With very little data and our technology, you can get something pretty compelling. And the reason why is that it's physical. And physics constitute a prior itself. It cannot do anything that is not physical. In reinforcement learning, most of the data comes from the character learning, and at the beginning they're stupid and they fall and they learn from their own mistakes and the rewards that they have, right? For more traditional generative systems like those of Ubisoft that you mentioned, there is no prior in principle. You could generate anything. And that's why they needed much more data. And if they're telling you that you can learn from basketball in 10 minutes or with very little data, is because there is another model, probably, or a set of priors imposed that limits the things that you can learn, right? In our case, it's physics, which is wonderful. Physics is a very good prior to have. Try not to generate stuff which is not physical sounds very illogical to me. And thanks to this being physical as well, we can do something that not a lot of people are doing, that is having the models in real time. The name of your podcast is Playing with Inference. Well, we are literally doing that. When you're using Later, you're literally playing with inference. And there is a model inferring in real time what the agent should do. It's very hard and very challenging to do this with a more traditional generative model. And when I say traditional, it's a model that just spits out data and is trained with data, like most of the modern kind of models. It's going to be very hard to do it in real time. And definitely on device, which we do, is going to be hard. And if you take on device like a phone, and a phone that the average person would have, it's just impossible, right? So that's an advantage that we have when we do this kind of stuff, right? And since everything is physical, the quality of the interactions is much more satisfying as well. And there is so much motion capture data and so much animation that is flawed, like that people point in YouTube glitches of, I don't know, things. With this wouldn't happen. It would be physical by default. So even if big studios want something that provides them with quality, this would be the way to go as well. And it's on device in real time. So yeah.
Unfortunately, I'm very stuck with creatures. So here I am thinking.
Time to get out the little ping pong balls, Ramon.
How many spiders do I have to torture? My understanding, as I unravel how this works, my understanding is that you're using then the mocap as for this to generate these priors that then feed into the RL stage. There's a world in which you could have, yes, okay, let me actually step back. In the ideal world in which I'm thinking, we have a lot of creatures that you can interact or that you can collect and you can train and all of this, right? And every time you say something, the creature acts on it. Now, down the line, we want these creatures to have certain powers that affect the world. The world is as physical as possible. There's some amount of magic, but the magic has rules. Mm-hmm. And even more long-term, I'm thinking the way we want to integrate LLMs is that they generate sort of magic in the world, but it gets grounded into the physical and elemental rules of the game. So I don't know, maybe it's known that fire spreads, but there's some new fire. It has some rules of physics. It has some rules has some weight, something, right? There's things that keep it grounded to that world. All of this to say that because I have these rules and because I have this physics system, I should be able to run simulations for then bootstrapping the animations or the behaviors of my monsters, as if I'm casting a power that is on the front and that casts some force, it should push my monster a bit backwards based in how that moves, right?
And it would look much better. Let's take any example of magic here. Harry Potter, Expelliarmus. What does it do? It applies a huge force on someone, right? To create a game with this, already with Latent, it would look much better than any Harry Potter game because it's literally applying a force and the guy's flying off. Freezing, I don't remember that spell, but that the guy froze and then it fell. Well, that would be physical as well. The force. Well, what better power it is than the force, right? This, you could literally get guys on the air and they will still behave physically, right? So it would look much better for the player to have physics-based generative physics in a game for this. And for your monsters, exactly the same. Any magic that you can have, it's also always sort of rooted in the physical world, right? When you think of a spell, it needs to do something, or a force or a fire or something that is rooted in the world. So I think that this would only help this kind of games like your dream game.
I completely agree. My point is more about, you're talking about Amos and freezing, but you're applying it on high school students on Hogwarts. But I want it to be applied to arachnids in the forest, right? I don't remember the name of the spider. I want the creatures.
Yeah.
So I guess my question is, if I were to assume this is what I'm doing, and I want to get these animations, is it with or without patent, or with or without latent, is the way there in a world where these creatures don't have any mocap data to train the priors, is it only alternative to then start the RL process without priors, and that's going to be costly because you're starting from nothing? Or are there other hacky ways? Is retargeting even a thing when you're going from a bipedal being to like a centipede?
I mean, I would guess, and correct me if I'm wrong, Jorge, but I would guess that you could probably do priors with hand animated stuff, right? Have
Yeah.
animators do a whole bunch of animations for the spider or, whatever creature, winged cat, whatever, right? And the more that you could do mocap data of creatures that you can reasonably mocap, like cats or dogs, right? But, worst comes to worse, you may need to create a bunch of animations to be the priors that are not mocap but are instead hand generated.
But I love actually that, because what you're bringing, Carl, because then if we were to extend to realms that are not captured by highly available data, then what I'm thinking is, okay, so is there a systemized way to bootstrap the priors with handmade animations, as you say? I think that's an interesting future, right? Like, how does that even look?
Yeah, and that's how does that even work? It's actually an open problem. A lot of these things, also the data that animators would generate is not physical by default.
Yeah.
Right? So it has its own challenges. And we have actually a lot of ideas with that. I prefer not to get ahead of myself, but we will solve it for you, Roman. We're going to give you arachnids.
This entire podcast is just so that I can get a lot of solutions on the plate. And there was this, okay, this is again more, I'm Mr. Tangent. There was this artist that I saw her post, and she was doing procedural generated creatures. These were four limbs, so like cheetahs, horses, but it was cool because it was based on the skeletal. You would choose more or less the shape, and then it will create the skeleton and like the actual bone system, and then the muscles, and then it will generate some animation based on that. Mm-hmm. And the more I think about this, is that's probably the way to go, in that you want some low level rule system that, again, this comes back to this combination of proc gen with generative systems, right? Like, you want some low level rule systems that you know how it works, you know how to control, and that's what you want to expose to the animator or the designer or the game developer. And then you want to then on top of that use your generative systems or your AI stuff, so that it takes advantage of the rules that you want to actually obey, but then it makes it magic for the parts that we would be incapacitated. It wouldn't be possible for a person to actually fully create every single animation for every situation in real time.
Yeah. No, but that's the way that it goes. I think that's one of the possible avenues. The procedural animation things are super cool. The stuff that some people are doing there, I look at them and it's super cool. Some guy comes with a crazy octopus and is, this is procedurally animated and he's behaving amazing, or a cat or something. The thing that they don't tell you is that they're working on that single cat months, defining exactly the rules and all of that. And then if the cat was bigger, it doesn't work. Or if it's not a cat or that specific cat, it wouldn't work. Maybe some do, I don't know. But procedural animation, it tends to be very ad hoc, make something work. It's not super general. That's what makes it very challenging, right?
Yeah. We're just about out of time, but I did want to get in one question that is sort of a broader zoom out question before we wrap up, which is, we've talked a lot about how you're really looking at this specific focus of reinforcement learning and deep learning to solve and build real-time animations. And I think one of the things that I find particularly interesting is the ideas of that particular approach are very different in a lot of ways than an LLM approach and how people are thinking about LLMs. And I think one of the things that I know folks who have been in machine learning for a long time are frustrated by this current moment is like, LLMs is not the sum total of AI. It's not the sum total of machine learning. It's like a facet of it. And so everyone's really focused on LLMs at the moment, but it's not everything. There's a lot more going on. And so for folks who are interested in, bringing machine learning into games and just this general space, but maybe have mostly been exposed to LLMs, as you get your soapbox as a machine guy who's been in machine learning for a long time, what would you sort of push people to be like, hey, you should look out for these other machine learning things, pair them with LLMs. Here's how to contextualize LLMs in broader machine learning for folks who are on the game side and not necessarily very familiar with the broader machine learning space.
Mm-hmm. I mean, LLMs are becoming very popular because they're easy to use and the results that they produce are really good for how easy they are to use. That's why everybody is plugging into a LLM and call it AI and saying, oh, we're making an amazing, and they're plugging into an LLM. And it's good. I understand it because it's a technology that is becoming established, right? And to these people, I would tell them, go ahead and use it. Bring new experiences to video games and to players. Please do. That's what I would tell them. Apart from making games cheaper and the workflow, which is great, try to bring this technology to the player too and to the developer in the experience of making the game. I love a metaphor here is TV. TV was black and white at some point, and maybe where people were obsessed with how making the broadcast more efficient or something, and at some point TV went to color. And everything changed. And it wasn't because of some efficiency point or something. It was because of the feeling. It felt different and there was no way back. And it was really hard to explain people that before the TV went to color. So these people trying to add AI to their games or something, I would say try to bring some color into video games as well, right? Don't be scared of trying new things. With respect to other AI techniques, I mean, I am in there. It's really hard. It's really hard to bring a hardcore ML technique to production. And in a case that makes sense, right? I know what we are doing makes sense, but it's not true of every machine learning technology, right? So try to leverage the tools which are already there to create new workflows or new experiences, and eventually, well, use latent as well. Why not? Because it would be the equivalent of the LLMs, but for generative physics animation. And once that's becoming established, it gives a different tool to developers as well to play and create new games. That would be my message. But I'm not a hardcore guy that says, if you're only using LLMs and you're not looking into pre-behavior, then you don't know. No, whatever works, right? And if you're interested in machine learning in general, apart from game development, I would encourage people to look into the fundamentals. I always say that. Start from the math, start from linear regression, build your way up to deep networks because it's a fascinating field. And you have the risk of getting hooked. But don't shy away from the fundamentals either. It allows you to understand these things very well, even when you come to deep learning.
Great.
Jorge, it's been a pleasure to have you. Thank you so much for doing this. If people want to find out more about Latent or want to reach out to you, where can they find you?
About Latent, just go to our website. It's latent-technology.com. And to reach me, just ping me in LinkedIn or send us a mail through the website. You can find me. We're also in Twitter, Latent, but with a 4 instead of an A, the first one. And you can reach us there.
All
and
right.
also see a lot of snippets that we publish now, these kind of cool situations.
I can't wait for my spaceship expands game.
Spiders.
Exactly.
We'll talk
no, that's what I'm gonna do right now. Like starting to move cool spiders. Okay, thank you so much, everybody. Thank you for listening or watching. To the next one.
Thanks for listening to the full episode. We really hope you enjoyed the discussion. It would help us out a ton if you subscribe to the show on your platform of choice, as well as shared it with folks you think would find it useful. You can always check out playingwithinference.com to get in contact with us, join our Discord, or just find the links to the episodes. See you next week.